Good afternoon, good afternoon, good afternoon. Happy Friday. Almost everybody's here. We are on the last lesson in this unit, in Unit 2. So if you would go to Canvas and give this a preview, you might, if you've done biology or you might have talked about succession before, usually comes up in ecology. Excuse me. See if I have a mint or something. But take a minute to look at this in Canvas. So as this is the last unit, Monday we'll do a quick review of all of the units, and then on Wednesday we will do the progress check in the AP classroom. And the progress check is the unit test. So give this a read. So there's two types of succession, primary and secondary. As soon as everybody's gonna give them another 5 minutes to get in, and then I will show our video, and then I'll give you time to go in the AP classroom and finish up anything that you need to finish up there. Okay, good afternoon to those who just came in. Happy Friday. All right, I explained to the rest of the group that this is 2.7 is the last lesson in Unit 2, so we're doing that today. So please read over this section, and as always, while you're in reading, always look at always look at the essential questions, what you should know for that unit, and the AP exam. Primary succession begins with bare rock. This kind of came up in one of the questions you had the other day, where if it's the glacier is going to create bare rock, and it'll have to start from scratch. So when you start from scratch and just rocking, you have to build up vegetation again from bare rock. That's primary succession. All right. Okay, I think everybody's here. I think we're only missing one person, but we're going to go ahead and get started.
We'll be covering topic 2.7, which is ecological succession. Our objective for today's video is to be able to describe what ecological succession is, but also to describe the different effects that ecological succession has on an ecosystem's structure. The skill that we'll be practicing at the end of today's video is a data analysis skill, and it will involve looking at a set of data and trying to draw conclusions based on the trends we see in those data. So ecological succession refers to a series of predictable changes that occurs in a forest ecosystem. There's two different types, and the first type is referred to as primary succession. In primary succession, the area has only bare exposed rock, so there's no previously formed soil. The process involves moss and lichen, which are species of plants that have their seeds or their spores dispersed by the wind. So the wind carries in those seeds, and moss and lichen are actually uniquely adapted to grow directly on rocks. They're able to break the rocks down by secreting acids, which releases the nutrients that they need to grow. And so if we look at a diagram, what we'll see here is that we start with this bare rock. Then as the wind carries in those seeds, the moss and the lichen are able to colonize or start growing on the rock. That breaks the rock down into smaller bits and eventually forms soil over time. In secondary succession, on the other hand, we're starting in an area that already has previously established soil, but the plants in that ecosystem have been cleared away by some sort of large disturbance. So that could be a wildfire, could be a windstorm, or even a human disturbance like clearing an area of land to use for agriculture. We're also going to see some pioneer species or some initial species move in, similar to in primary succession, but the big difference is that these first species to arrive are going to be grasses, sedges, and wildflowers, and these are species that are quick growing, and they have their seeds dispersed by the wind or by animals. So if we look at a diagram of secondary succession, you'll notice the big difference is that there is established soil already existing. It's just that a disturbance has cleared out the existing plant community, and that leaves the soil open for these pioneer species to come in and start to take up root. Now we'll talk about the basic steps of succession, which are common to both primary and secondary. So really the only difference between those two is the starting stage, whether or not there's already established soil. After that, it's relatively the same process. So it's important to understand that these stages of succession, or this process, is marked by which types of plant species dominate the ecosystem during each stage. And that's because different species are adapted to the different conditions that occur in each phase or each stage of succession. So we always start with pioneer or early successional species. These are the first species to appear in the area, and they are able to become established either on the bare rock, if we're talking about primary succession, or in the recently disturbed soil, if we're talking about secondary succession. They share some characteristics, which is that they are dispersed by the wind, meaning that their seeds are often carried by the wind to the area, or by animals who may eat the seeds and then disperse them in their waste, or the seeds may get stuck to the animal's fur. So we have a picture here of the wind blowing seeds to help us remember that pioneer species need to be able to be dispersed by the wind.
If English isn't your first language like me, and you want your writing to reflect your voice, consider trying Grammarly Pro today to elevate.
Or by animals. Some examples would be moss and lichen if we're talking about bare rock that occurs in primary succession, or wildflowers, plants that produce berries like raspberries, or grasses and sedges if we're talking about secondary succession. Pioneer species are always followed by mid-successional species. Mid-successional species appear after a couple years where the pioneer species have built up the soil, so it's a little bit deeper and a little bit more nutrient rich. And so what happens is those pioneer species, as they grow and die, their biomass or their organic matter gets added to the soil, and that increases the richness of the soil and increases the depth over time, which eventually enables the mid-successional species to come in. Those mid-successional species share some characteristics as well. They're going to be fast growing. They're going to be a little bit larger than the pioneer species, so they're going to grow a little bit slower. They're typically going to need a little bit deeper soil with more nutrients than those pioneer species were able to tolerate. But they're also able to be tolerant of full sunlight, and that's because there's no shade in the ecosystem yet. If we look at a diagram, we can see here that it takes some time for the shrubs and these smaller trees, which are mid-successional species, to arrive, because those pioneers have to build up that soil depth for them. And they're also just species that grow a little bit more slowly. So these trees, take years to start to develop. And so they're not going to be seen right, the first or second year after a disturbance. If we want some examples to remember, we can think of shrubs and bushes, things that take a couple of years to start developing. Same thing with trees that are fast growing. So pine and cherry are two great examples of mid-successional species. And then we have late successional species, which, as their name implies, are the last species to colonize or to start growing in an area. We also sometimes call these members of a climax community because a climax is at the end of the transition, and so it takes them quite a while to arrive. So they are going to be able to start growing after the soil has been deepened and enriched further by this process of the early and mid-successional species dying and having their biomass and their nutrients added to the soil. All of these late successional species share some characteristics. Those would be that they are large, slow-growing trees that are tolerant of shade. Now, they take a long time to grow and develop, but they're able to develop in the shade of these mid-successional species. That's an important characteristic of them. And they need deep, nutrient-rich soil to anchor their roots because they're oftentimes very large trees that can grow to hundreds of feet tall. Maples and oaks are great examples, as well as other large trees that reach heights of hundreds of feet. And if we look at this diagram here, what I like about this is it helps us remember that we need this soil to be built up over time. So we would not have deep enough soil, a couple years or even 10 or 20 years after primary succession. It takes hundreds of years to get soil deep enough to support the roots of these large, shade-tolerant and slow-growing trees. And so again, we would call this here a climax community because it's at the end of succession. It takes hundreds of years for the soil to be built up and for these trees to grow and emerge from the canopy of the mid-successional trees. So as a reminder, that early, mid to late successional process is common to both primary and secondary succession. The main difference is just the starting material of those two. And so primary succession, you'll remember, starts from bare rock. This is an ecosystem that has not previously had soil present. And this can also often occur after a volcanic eruption or after a glacial retreat. That's because those are both events that will leave bare rock without soil on top of it. And so very important to remember that moss and lichen are the colonizers or the pioneer species in primary succession, and that's because their spores or their seeds are easily blown in by the wind, but then also they're uniquely adapted to grow on rock. They have a unique adaptation that enables them to secrete acids into the rock. Those acids will actually break down or chemically weather the rock so that the minerals in those rocks that have the nutrients that the moss and lichen need will be released, and those moss and lichen can then absorb the nutrients into their bodies. So these are things like potassium, phosphorus, and nitrogen. And again, this is really critical to primary succession starting. Without this chemical weathering, we wouldn't have the formation of soil. So as the rock starts to break down, there are smaller bits of rocks that mix together with the dead biomass or the dead organic matter from the moss and the lichen as they eventually die. And all of that kind of mixes together and forms this initial rocky, shallow soil. So if we look at this picture here, we can see this is a lava flow where there is exposed rock after the lava has cooled, and it's going to be colonized first by these lichen. And then we have this diagram that we did look at before, but it's a great reminder that we have this bare rock, and then eventually the rock is starting to be broken down by the secretion of the acid by moss and lichen. And then eventually we get just the very beginnings of really rocky, shallow soil here. And then from there, the process is the same as we've discussed. We have our pioneers, our early successional species, followed by our mid-successional species, followed by our late successional or climax community species. And finally, we'll wrap up by focusing in a little more detail on secondary succession. So remember, this is in an area where there's already established soil, but most of the plant community has been removed by some sort of disturbance. So pioneers are still going to be the first species to arrive in this area, and they're going to be plants that have their seeds dispersed either by the wind or by animals, and they're going to be fast growing and sun tolerant, but they're going to be wildflowers, grasses and sedges, as opposed to the moss and lichen, who are our pioneers or colonizing species in primary succession. Important to point out that the soil is already established here, and sometimes it's even enriched if the disturbance was a forest fire. Now that's because forest fires burn down the previous plants that were in the area, and they return a lot of the nutrients that those plants had been storing back to the soil. So soil in the wake of a forest fire is often actually very nutrient rich and really jumpstarts the process of secondary succession. So if we look at this diagram here, I know we've seen this one before, but it's a great reminder that we do start with a disturbance of some sort, often a forest fire, but it could be a human disturbance like clearing land for agriculture, or even just a windstorm or a flood, anything that dramatically reduces the plant community and basically enables these pioneer species to come in and dominate. So remember, our pioneer species in this case are going to be grasses, sedges, weed species that have their seeds dispersed by the wind. They're also going to be very fast growing. They're going to be full sun tolerant, so they can handle that full sunlight. They colonize the area. They eventually die and build up the soil a little bit deeper for our mid-successional species, who are faster growing trees, bushes, and shrubs. And then finally, we have our late successional or our climax community species. I do want to point out that this process of secondary succession is faster than primary succession, but it can still take upwards of 150 years for this climax community to form. That's because these late successional species are very slow growing. They need deep roots with a lot of nutrient-rich soil to nourish those huge trees that are going to grow and anchor them. And so it is still a relatively slow process to reach a climax community. So for practice FRQ 2.7 today, we're going to practice the skill of analyzing data and drawing conclusions from those data. So what we have here is a graph showing the number of spruce trees per hectare in an ecosystem as time goes on after a glacial retreat. So based on this graph, I want you to explain whether or not you think the spruce tree is an early, middle, or late successional species. And remember that with explain, you need to justify your reasoning for this.
Okay.
This is Christmas at all.
Oh. Okay, so come back to Canvas. He has, Canvas has those diagrams. And I kind of feel like this unit should have come before the other one on ecological disturbances, because ecological disturbances cause secondary succession. So you should have understood what succession was before they talked about disturbances. But be that I don't write the curriculum. So this is a diagram, kind of more simplified than what he had, but because the ones that he had in the video, the ones that you typically see, but it's simplified in that you clearly see what the components are in each stage. So do study this one as well, so that you see that you start with bare rock. And he said that's the basic difference with primary and secondary is you're starting from bare rock. There are no plants. And again, succession is about the plant community that grows. And then if lichen and moss are those kinds of, they're plants, but they're plants with shallow roots. So they don't need much. They can get the water from the surface that falls on the surface of the rock. So they don't need to have deep soil or anything, but they create the soil because they give off chemicals that break down the rock. So between weathering and the plants that are growing on the rock, this is what creates soil. And then other things that come, once they start doing that, then other things can come along and start the decomposition because they are living things. They're going to die and decompose. So they add nutrients to the soil. Once you add nutrients to the soil, bigger plants can grow. In this case, bigger plants mean grass. Okay, and then the grass goes through the same cycle where it's digging down and creating burrows and adding nutrients to the soil. So then trees, not trees, shrubs, short trees can start to grow. And then eventually taller trees can grow. And then in that state, what they call the climax community, you mentioned that the because they're taller trees, they create a canopy. A canopy is kind of like a covering, in this case, a covering of leaves. And they block out the sun to things that are on the ground. So typically in a climax community, you don't have a lot of vegetation on the ground because of the trees blocking out the sunlight for those things. All right, so then again, secondary succession, they will have the same pictures, except they start off different. Secondary succession becomes necessary because of a natural disaster, like a forest fire, a tornado destroying the place, floods washing out all of the vegetation. So something disturbed the ecosystem to wipe it out, but it doesn't wipe out the soil that is already there. So things can start growing faster. So they still have to start from scratch and grow back all over again, but they don't have to create the soil. The soil is already there. So this happens faster. So read through that. What he did not talk about was this section on types of species. So I will do that later. But what I want you to do is to look at this, then go to the AP classroom. Probably mine went to sleep. Sure he did. And you've been assigned 2.7 there as well. Now I will, as always, make a copy of his FRQ, and you'll see that pop up later in the grade book. Come on, switch. And those of you who need to finish, you need to go ahead and finish whatever it is you need to finish. There we go. All right. So please work on these. As I always assign the videos, because the more information you get, the better. Videos are not required, but they're there as a resource. But answering the questions is a graded assignment. All right, so I'm gonna stop talking, do attendance, let you get started on that. And then the scores that hopefully you went in and redid the other scores, and I'm gonna go ahead and put those in the grade book as well. I didn't have to send out any letters in this class yet to you all, but some of y'all are borderline. So if you know you're borderline, please go in and complete any assignment that is missing. Appreciate y'all. Everything went to sleep on me, even the attendance. Got a lot back in for that. With all this cybersecurity, you're always having to verify your ID. Just want to do attendance. So we are live streaming again. I'm off probation. So I will go in also and make sure that all of the videos for this unit are in your playlist. I just put that one in, but I will make sure that all of Unit 2, I think we've been out on probation for the whole of Unit 2. So I will go in and make sure that all of those videos are on your playlist. Okay, so I've updated the playlist in your classroom list. It has all 7 Unit 2 videos. So if you wish to catch up on those, you can. And hopefully there'll be no more violations for the year, and then we be able to keep saving these. Abigail. Like Abigail, you're falling behind. You got several sections. Like, that you need to finish for Unit 2. Amelia, you too. And Gianna. Please try to get these finished over the weekend so that you're caught up in time to do the exam. The exam is Wednesday. I want to say it's Wednesday. I'm looking at what night, and next Friday is the day before the break. I might just do it Friday and then do, because some of you got some catching up to do quite a bit. Plus, I put the videos in your playlist, but Monday we might go over pioneer species, invasive indicator species, and keystone species. And then do the review on Wednesday and test on Friday. I'm thinking that we'll just end the week with the test and then you come back and start the new unit when you come back. That's my thought at the moment. Looking at all the zeros I just put in the grade book. And folks, if you didn't do 2.4 and 2.5, those went in just now as a 0. I will do 2.6 and 2.7 together as a unit as well. Being as you're all still working on 2.7, hold off on entering that score. But a lot of you still have 2.6 in the AP. That's why I said I'm going to put this test off till Friday, because a lot of you still have 2.6 to do as well in the AP classroom. So need time, you need time. But folks, don't waste the time. Some of you are doing other things other than your AP work during AP time. Majority of you get it, knock it out, and everybody's up to date, and then there's a handful of you that are dragging. We have to keep on going because for those who are taking the test, there's a lot of information we still have to cover, so we can't afford to keep holding back, waiting for folks to catch up. So thank you for those of you who stay on task. Got a couple of people who log in for attendance. Whether or not you're taking the AP exam at the end of the year, you are taking the exam at the end of the course, and you do want to pass the course. So please keep up. All right, Friday is a tutorial day, and folks are gonna, I had a lot of, because I sent out a lot of letters. So a lot of people are coming in at 1:30. So I'm going to log out at 1:30 so I can log back in. So unless you have a question for me, you are free to log out and have a great weekend. See you next week. Enjoy the good weather. It's warmed up a little after all that freezing. I had a greenhouse. That wind and weather tore up my greenhouse, and the poor little plants are frozen. Gotta stop, but I'm gonna build a new one for next year. All right, have a good one, everybody.